So a couple of announcements before we get started. I hope you got my email that says the books are in the bookstore. This video does use page 13 in the course notes book, or in other words, I usually call it the blue book, and page 3 in the in-class exercise book, which I usually call the orange book. PDF files are available in the Brightspace Datasets module for those who do not have their books yet. In almost every class, we'll be talking about data in some way, shape, or other. So we're just going to get started by going through some basic definitions, and to do that, we'll use this small example here of a data set. In this data set, there are 4 variables. Okay? Variables are characteristics of the subjects, and the characteristics we have here are height, weight, eye color, and number of siblings. The variables are usually the columns, okay, but not all columns are variables. And we'll come back to that in just a minute. An observation is usually a row in a data set. And so here we have 5 observations. And before we go on, I want to make a note about my use of the word usually here. Variables are usually in columns. Observations are usually the rows. Data must be organized in this way to be analyzed using any statistical software. But there's nothing that will prevent someone from typing it in the opposite way into a spreadsheet. So, as we said, variables are height, weight, eye color, and number of siblings. Characteristics of the subjects. A related word that sounds very similar is values. The values are the individual numbers or words in each column for each subject. So, for example, we look here, there's 20 total values. So, for example, 135, 200, 150, 160, 105 are all values of the weight variable. Brown, blue, green, hazel are all values of the eye color variable. Now, what about this first column here that we've been totally ignoring? ID number. Okay, that is an identifier. It's not a variable because it's not something we're going to find the mean of or draw a graph of. It's simply there to identify each observation. So it's there for purposes of data entry and keeping track of things, but it's not something that we're going to analyze. So in this data set, although we have 5 columns, we only have 4 variables. Oftentimes there's multiple columns, usually at the beginning, that identify. There could be an ID number and a first name, last name. All of those would be identifiers, not variables. There are 2 basic types of variables, numeric and categorical, and it's fairly self-explanatory that the numerical ones take on number values, and the categorical ones, the values are categories. For example, eye color. They're often called levels, as we'll see later on in the course. Numeric variables can be further broken down into discrete or continuous variables. And the definition of discrete is that it takes on a finite number of values. In other words, like if you had a pencil and a piece of paper, you could write down all the possible values. It might be a long list, but you could write it down. Continuous, on the other hand, has an infinite number of values. A value is actually a point on the number line, and you could think of it as having like more and more decimals. So it could be 8.2 or 8.27 or 8.274 or 8.2741, depending on how fine of an instrument that you have to measure that number. So you get the idea. It could just go on, and we could never write them all down. So we often think of the continuous variables as being the ones with decimals and discrete as being the ones that are whole numbers. And that is often the case, but we really need to think about it in terms of its actual definition. Discrete has a finite number of values. We could list them. Continuous has an infinite number of values. We can't list them because the decimal places could go on and on. So, for example, if you go to Walmart or Hannaford and you want to get some golden sweet whole kernel corn, you would have a choice of 4 different sizes. And those sizes are 8.75, 15.25, 29, and 106. There are decimal points in some of these. There are only 4 possible values. You can't go to the store and get, say, 10.37 ounce can of corn. You only have 4 choices. We can write down those 4 choices. So can size is a discrete numeric variable. So discrete numeric variables are often things you count. For example, number of siblings, 31020. Okay. You can't have 2.7 siblings. It's an item that we're counting. Continuous numeric variables are usually things you measure. In our example here, height and weight are both things you measure. You could measure them finer and finer, even though we have weight written down in whole numbers here. Just the fact that it's whole numbers doesn't make it discrete. We could say, well, somebody weighed 135.2 or 135.28, and etc. So it's only the scale that's determining how many decimal points there are. So let's list some more examples of the discrete and continuous numeric random variables. Let's start with continuous because that's usually easier to think about. Okay, so think about, for example, being in one of your science labs and things that you've measured. So any kind of a length or distance, usually if it's a really long length. We've already mentioned weight. Another one you might measure is mass. Velocity or speed, time, precipitation, volume, area, and there's many more. Now over to discrete, and remember it's usually things you count. For example, number of students in a class section, or the number of credits a student is taking, or the number of rooms in the house. Or, for example, population is a count of people in some geographic region, for example, per county. And this is a census year where the government is undertaking doing a complete count of everyone in the country. And again, there are many more examples of discrete variables. So next, pause the video and see if you can come up with some examples of categorical variables. Did anyone come up with age as an example of a numeric variable. So what about age? It's a pretty commonly used variable, but what kind of variable is it? If I asked you how old you were, you might say, I'm 19. But unless it's your birthday today, you're 19 and some number of months and some number of days. And if we looked on your birth certificate, we could probably determine the number of hours and maybe even the number of minutes. So it's something we could measure with finer and finer granularity. Technically, age is a measure of time, so an argument could be made that it's continuous. But practically, we treat it as discrete unless someone is less than 10 years old, in which case, like being 8.5 is very different than being 8. Or we are looking at a survey question. And how do they often ask about people's age in surveys? They do it with a multiple choice question, in which case, if you're looking at survey results, you can't tell how old a person is, only what category their age is in. So we can't do anything that we would normally be able to do with a numeric variable, like find the mean, etc. And when the data is gathered this way, age is a categorical variable. So to tell what kind of variable age is, you have to look at the actual context in the data itself that was gathered. So possibly favorite color or lifesaver flavor. Another example would be genre of music. So just to add a note here, we couldn't extend this genre of music to the level of saying like, oh, what everybody's favorite album is, because that list would be too long. There'd be many thick catalogs before you could list every album of every artist. So that's not something that we would ever be able to like make a graph of, like which are the most popular albums. Maybe if you did it for one particular artist, that might have a limited number of values. So when you're really thinking about this, we think of it as words, but again, like discrete variables, it has to have a limited number of values before we can actually think about analyzing it. The next example we're going to look at is in the Orange Book on page 3. So this is some data collected from a village in the New Guinea rainforest. This is a picture of some of the inhabitants of this village, and this lower picture is a picture of a cassowary, which is one of the things they hunted. A cassowary is a large bird. It's the third largest bird behind the ostrich and the emu, and they're usually wary of humans, but if they're threatened, they can get very vicious. The inner toe on their foot has a 5-inch claw that can strike a lethal blow. And there was a guy in Florida last year who was keeping one for a pet and was actually killed by his cassowary. But mostly that's urban legend kind of stuff, and the last confirmed killing of a human being by a cassowary was over 90 years ago. So at this point, you should pause the video and take a couple minutes to try to answer the questions on page 3 about the data set. There are 9 rows, which tells us there are 9 observations. There are also 9 columns, but are they all variables? ID number and name are not things that we're going to analyze. They're just there to help keep track of the data. So that leaves us with a total of 7 variables. Status is the only categorical variable. pig, cassowary, and fish. These are all the weights of the amount of that the hunters caught in each one of these types of animals. When you are finished watching this video, you can go ahead and do the Datasets web assign.